Hi, we're going to talk today, 8-7, lesson 17, distance on the coordinate, distance on the coordinate plane. We're going to find, looking at a coordinate plane, we're going to be able to find the distance between any 2 points. And we're going to use that information after we learn how to do it, and we're going to extend it in a couple different ways. I'll wait until we get there to explain that second part to you, but the key is going to be using the Pythagorean theorem, using these building blocks from the past couple lessons to find distance on the coordinate plane. That's my hint to you. Think about Pythagorean theorem and distance as we talk about this overview, and maybe you'll figure it out before I give you the final answer. Okay, let's head on over to our sketch pad. And on our sketch pad, again, we're going to find the distance. Whoops, we need a pencil, not our line tool. Finding the distance on the coordinate plane. And what is the coordinate plane? Remember, the coordinate plane is this thing we have this y, we have our x-axis and our y-axis. That's the coordinate plane. And we're going to use the Pythagorean theorem to find distance between points. Well, if I wanted to find, let's just start off with kind of the general question and kind of the problem that we're facing. Well, if I want to find the distance from point A to B, let's pretend point B was right here. Let's just start and pretend it was here. Well, I would know the distance would be 1, 2, 3, 4, 5, 6, because each edge of each square is 1, right? 1, 2, 3. So this is, 1, 2, 3, 4, 5, 6. So here A to B would be A to B, that'd be a distance of 6. But the problem is that points usually don't line up real nicely on these coordinates, or at least on the same line of horizontal line or vertical line. So we have to figure out how far it is from here, here to here. We could use our line tool and make it exact. So how far is it from here to here? How far is that? Well, I can't really figure that out because, well, that's, if I was, this is kind of 1, maybe, I don't know where 1 is, 2, 3, it's somewhere in between. It might be a little more than 4 and a little less than 5 if I had to guess, but I don't really know. But I want you to think about this. How does the Pythagorean theorem, how can that help us get the exact distance from point A to point B? Okay, let me think about that. And the answer is we're going to draw. So if you pause, maybe pause and think about it. How could I draw a triangle? Could I draw a triangle that would help me find this distance? If this distance, imagine this distance was a hypotenuse of a right triangle. Where could I draw edges that would be legs of a right triangle? All right, well, now let's go and give you the answer. So I'm going to take, I can find a point that's on this, where this line is horizontal, and I draw a vertical line through this other point. I can get to a point right here. I can get to a point right here, and I can draw a right triangle. The other place I could do it, if I drew a horizontal line through B and a vertical line through A, I could get to this point. And either one of those points will work. But we'll choose this one just for the sake of having to choose one. So now I can draw a right triangle. I can draw this edge and this edge. And then I could draw my hypotenuse, which is the distance from A to B. My hypotenuse is my A to B. Okay, and how do I know this is a right angle? Well, I know it's a right angle because it lines up right here on the edge of a square. So that's a right angle. That will always be a right angle. I got a vertical line and a horizontal line. Those always meet in right angles. That's another way to think about it. So now I can actually go about finding my distance from A to B. Well, how do I do it? Well, from point, we're going to call this point X. From point X to B is how many? It's easy to count. 1, 2, 3. And how far is it from point A to X? Well, that's 1, 2, 3, 4. So my legs are 3 and 4. So what is my hypotenuse? Well, I can either remember one of my magic triangles, one of my perfect triangles, or I could use the Pythagorean theorem to remind myself what the answer is. Well, let's plug it in. 3 squared plus 4 squared equals c squared. That's 9 plus 16 equals c squared. So 25 equals c squared. So c equals 5. So the distance from A to B in this case is 5, a nice round integer. So we're going to box that up and say 5. Okay, so we're going to do this a couple more times. I'm going to let you practice it, and I'm going to give you a few more examples for you to work on. Okay, so here, what is the distance from point A to point B? Let's just use the exact same strategy. And for those of you who think you already have it, I want you to pause and try. The first thing to do is to identify the point that turns AB, that distance, into a hypotenuse. Okay, well, I'm going to choose, okay, so I assume you've paused and tried. Well, I'm going to choose this point here, right? It's the horizontal line that goes through B and the horizontal and the vertical line that goes through A, and I meet at this point. I'll get rid of my dashes, and I'll just draw my 2 legs here and figure out how far my legs are. Well, that one's 1, 2, 3, 4. And this one is 1, 2, 3, 4. Now, I can count them out like this, or I can do the other thing, which is to subtract their coordinates to get that 4. So let's get a little bit more advanced here and identify the 2 coordinates for y. Well, 3 minus a negative 1, right? We find the difference, we're subtracting. So that equals 3 plus 1, and there's my 4. Over here, I have my 6 and my 2. So those are nice positive numbers. So it's easy to figure out that this distance from B to X, call that point X, is 6 minus 2, which equals 4. So my 2 legs are 4. So I have 4 squared plus 4 squared equals c squared, my hypotenuse. 16 plus 16 is 32 equals c squared. And so c equals the square root of 32. And that simplifies for those of you who are, maybe your teacher doesn't make you do this, but it's square root of 16 times the square root of 2 equals c. Right? Remembering our rules of simplification of radicals. And so that's 4 square root of 2 equals c. This is non-simplified. Some teachers, I think that some teachers may leave it at this level in 8th grade, but I prefer, I'm just going and showing you the advanced route. And this was, I think this was an optional lesson that we learned earlier on how to simplify square roots. Okay, so this distance is c is equal to 4 square root of 2, or unsimplified, it was the square root of 32. All right, let's do another one. Let's do 2 more, and I'm going to let you do these ones on your own, because this is going to, your homework is going to be doing a lot of problems, or I think 4 problems like this. So homework help, I want you to pause plus try. All right, now I assume you're back. I assume you've paused and tried both of these, and some of you may have noticed something interesting about this one, but we'll get to that one in a second. So here we're going to make our triangle. This side is 1, which is -1 minus -2 -1 plus 2 equals 1. Or you could have just counted it out. Here you could count it out at 4, or you could say it's 5 minus 1. So that's a 4. That side's a 1. So our hypotenuse, c squared, is equal to 4 squared plus 1 squared, which is equal to 17. So c equals the square root of 17. Square root of 17. Okay, and now this one here, we don't need the Pythagorean theorem. Just don't need it. We can just count it out. 1, 2, 3, 4, 5, 6. Or we could have said, well, 8 minus 2. So our answer either way is 6, whether we counted one at a time or we use subtraction of our coordinates. Great. Okay, now we're going to do one more thing, and that is this. We're going to answer the question about, are these right triangles? So what we're going to do we're going to use this lesson that finds distance between 2 points, and then we're going to use last lesson, the converse of the Pythagorean theorem. So this is a two-step. We're going to use 2 steps to solve. First, we're going to find all distances using using the distance, using lesson 17, which is our distance formula, which is really the Pythagorean theorem. Pythag theorem. And then secondly, we're going to use the converse of Pythag theorem to see if we have a right triangle. Okay, so how do we do that? Well, we're going to find this distance. This one looks like the leg. That looks like a leg here. And this one looks like a leg here. So let's go about finding those things. So here we have 1, 2. So we're going to find this distance. So forget about this and forget about this. We're just going to see if we can figure out this distance first. We're going to have to do this 3 times, once for each line. So this one here, we're going to build our right triangle here. And so here we have 3, and here we have 4. 1, 2. Oh, nice. So we know that 3 and 4, that makes this a 5. This side here is 5. We could do the 3 squared plus 4 squared equals c squared, but we know that this is a magic triangle, 3, 4, 5, where we don't have to really do that math. Here we got a 1, 2, 3, 1, 2, 3, 4. We have another 3, 4, 5 triangle. So this one here is also 5. So 1, 2, 3, 1, 2, 3, 4. Okay, good. So we have 2 triangles with sides of 5. Or our big triangle, our ABC, triangle ABC, side AC equals 5. And side AB equals 5. So now we want to find out what CB is. Well, here's our right triangle here. We're going to draw this. I'll draw this one here. You could have drawn this one here. You could have chosen this point, but then you would be kind of walking on top of work that you've already done. So I kind of wanted to keep it on the outside here. So here's a 1, and this one's 1, 2, 3, 4, 5, 6, 7. So this side is 7. So I have to use my Pythagorean theorem. 1 squared plus 2 squared equals c squared. So that's 49 plus 1 equals c squared. So 50 equals c squared. So C equals the square root of 50. So here's the square root of 50. So now we can kind of get rid of all the rest of the work. And we're just going to, let me get rid of all this extra work here. Whoops. Whoops. Keep getting rid of this. Okay, so see how I get rid of all this other work. So we can just see the key pieces of what we're trying to do. Okay, so now we have, I'll get rid of these arrows even because they're kind of unnecessary. So now we have a triangle with sides of 5, 5, and 50. So we have to ask ourselves, you know, is this a right triangle? Well, the question is does a squared plus b squared, does that equal c squared? And if it does, then this is a right triangle. And that this would be our right angle because these are our, we're calling these our legs. So let's give that a go. 5 squared plus 5 squared, does that equal the square root of 50 squared? Well, 5 squared is 25. 5 squared is 25. And the square root of 50 squared is 50. The square root of any number squared is that number. So 50 equals 50. So yes. So the answer is yes. This is a right triangle. Happy cat. Happy cat on that. Okay, now we're going to do this one over here. Let's do the same method. And if you want to pause and try at this point, I encourage you to do so. But you don't have to if you don't want to. If you still don't get it, I mean, the key thing here is we're going to find this distance, and this distance, those 3 distances, and we're going to see if we have a right triangle. So I'm going to do this in orange, or let's do it in blue. All right, so this distance here is 2, and that distance is 1, 2, 3, 4, 5. So this is 5, and this is 2. So we have 2 squared plus 5 squared equals c squared. So that's 29 equals c squared. So this is the square root of 29. Square root of 29. So let's just go ahead and get rid of this, and let's write that in. This side is the square root of 29. Okay, well, this one here is, what is this one? 1, 2, 3, 1, 2, 3, 4, 5. So this is 3, and this is 5. So I get 3 squared plus 5 squared equals c squared. So I get 9 plus 25 equals c squared. So that's the square root of 34. 34 square root. So that's the square root of 34. Okay, now this last one is 1, 2, 3, 4, 5, 6, 7. And this one here is a 2. So c squared, that's this one, is c squared equals, let's do it all at once. 49 plus 4. That's a squared plus b squared. So c squared equals square root of 53. So c is the square root of 53. So let's get rid of that. So this is our long side because square root of 29 is less than the square root of 34, which is less than the square root of 53. So we have to look and see if a squared plus b squared, does that equal c squared? If it does, it's a right triangle. If it doesn't, it is not. And we proved that last lesson. So this is going to be kind of easy to do. Square root of 29 squared is 29. The square root of 34 squared is 34. And the square root of 53 squared is 53. So it's 29 plus 34 equals 53. Well, Let's see. No, it equals 63. Since 63 does not equal 53, so the answer is no, this is not a right triangle. And we'll give ourselves, I mean, just because the answer is no, we can still give ourselves a happy cat because we got the right answer. Proving, of course, that this is not a right triangle. Okay, let's go. And now this is your homework help. Oh, homework help. And you're going to find the distance from A to B and identify if this is a right triangle. Okay, so pause and try. And I assume you are now back and ready for action. So let's get on with it. The distance from A to B, this is just simply the Pythagorean theorem one time. So this is 2 minus -1. So this is 3. That's 2 plus 1 equals 3. And this here is 5 minus -3 equals 5 plus 3 equals 8. So this side is 8. So this here side here is a squared plus b squared equals c squared. This is c. So you get 9 plus 64 equals c squared. So that's 73 equals c squared. So c equals the square root of 73. Good. And finally, we got to identify if we have a right triangle. Okay, well, let's figure out this edge here. Well, this edge is 1 and 2. So that's 1 squared plus 2 squared equals c squared. So that's 5 equals c squared. So this is the square root of 5, this side here. This side here is 2, and this side here is 4. So we have 2 squared plus 4 squared equals c squared. So here we have 4 plus 16. We have 20 equals c squared. So c equals the square root of 20. This is the square root of 20. So let's just write that in, get rid of the extra stuff. Square root of 20. And this one is easy. We can find our hypotenuse, our long side, by just saying, well, it's 1, 2, 3, 4, 5. This is 5. So the question is, this looks like our right angle here. So, or the question mark, is that a right angle? So let's say a squared plus b squared and see, does it equal c squared? Well, the square root of 5 plus the square root of 20 squared, square root of 5 squared plus the square root of 20 squared. Does that equal 5 squared? Well, square root of 5 squared is 5. Square root of 20 squared is 20. Does that equal 25? Well, yes, 25 equals 25. So yes, this is a right triangle. So I'll go ahead and mark this, and I'll get rid of my little question mark because it is a right triangle. Let's lay down our happy cats. Good. And let's go into our last question. This is a challenge, and the question is this a square? Well, it looks like a square, but can you prove it's a square? And what do we know about squares? Squares have 4 equal sides. That's my hint. And you have everything you need to be able to answer this question. So that's my challenge to you. So I want you to pause and try. Okay, now I assume that you've tried it. Now let's look. Let's see if we can figure out how long each side is. Well, this side is 1, 2, 3, 4, 5, and this is 2. So F here, this length of this side over here is the hypotenuse of a triangle that has sides of 5 and 2. So 2 squared plus 5 squared equals c squared. So that's 29 equals c squared. So that's the square root of 29. So f equals, this is the square root of 29. Well, let's look at this side. Well, this side is 5 and 2 also. So G has the same length because it is the hypotenuse of a triangle with 5 and 2 as its legs. So there we got C is equal to the square root of 29. So this is the square root of 29. We're well on our way to proving that this is a square. Well, let's see, look at this one. Well, this one's 2 and 5. So when you do your Pythagorean theorem, you're going to end up with this side I being the square root of 29. And finally, side H. Well, what do we have? We have the H is the hypotenuse of a triangle with sides with legs of 2 and 5. So H is also the square root of 29. And so the answer is, square or quadrilateral A, B, C, D is a square because it has 4 equal sides. Now, some of you may be saying, and you might be right, it could be a rhombus because I haven't proved that these are right angles. I didn't prove that these are right angles. But let me prove to you really quickly using another building block that we already learned about right angles. And that is that this must be a right angle because I'm going to look at the slopes of these lines. And if the slopes of these lines are negative reciprocals, then they are right angles. So what is the slope of this line? Well, the slope of this line, the rise over the run. So let's look at the slope of CD. Well, the rise, let's see here. If we go from C to D, the rise is -2. We'll go rise over run. The rise is -2, and then the run is 5. So that's -2/5. What is the slope of BC? The slope of BC. Well, the rise is 5, and the run is 2. So these are negative reciprocals. So this is indeed a right angle. And in a rhombus, if this is a right angle, the opposite angle is the same. And if these are both right angles and these angles are equivalent, then these also must be right angles. You could go about proving that all by using this slope stuff. The slope, you could just do all of the slopes and you'd find out that these two slopes are 5/2 and these are both -2/5. And that would be also a way of proving that all 4 angles are 90 degrees, because I'm not sure that we actually learned about the properties of rhombuses. But we've shown that all sides are equal and we have 4 right angles. All right, that's it. That's it for today. Or that's it for this lesson. You may be doing more than one lesson today. And that was lesson 17, distance on the coordinate plane. We're going to move forward with same building blocks and get a little bit, learn a little bit more in lesson 18 as we march forward through lesson 23, which marks the end of the 8th grade Common Core Eureka Math school year.